Are you even noticing exceptions in your production environment? Stay tuned to learn how to keep track of the errors that are occurring in your application right now. Hi, my name is Bernhard, I'm a software engineer working in Vienna, and in today's video I will introduce you to Sentry, a free web-based exception monitoring tool that can be integrated in most programming languages and frameworks. After watching this video, you will have a good understanding on how to integrate Sentry in your PHP and Python applications and trace your application errors in real time. There are two parts. First, I will introduce the concept of exception monitoring tools and Sentry, and finally I will guide you through a practical setup. Let's get started. So why do you want an exception monitoring tool? When and not if there are errors in your application, you want to know about them as soon as possible. In many legacy applications, you will probably find code that writes error messages in log files or sends them via email. Sending emails sounds fine until you wake up to an inbox filled with thousands of messages and you can't really go through all of them. What you really want is a system where such exceptions are systematically logged. You want them to be aggregated by the root cause, you want context information, you want to be able to sort by date of occurrence, number of impacted users, etc. So what you really want in your exception monitoring tool is to get a big picture overview of what the error is, what caused it, and what happened afterwards. Additionally, you want as much context as possible. You want to know, did the user log in with a specific browser? Did he send a special kind of request before the error occurred? What were the parameters of the request? Debug infos like that would help you tremendously figuring out what happened and how to fix it. Now, Sentry is exactly such a tool and allows you to manage your exceptions. Once you have integrated it into your applications, you are suddenly able to answer questions like, when did this error occur the first time? What happened before the error occurred? Did it occur only for specific users or for specific browsers? How many users were affected? And so on and so forth. So now we know that we need some kind of exception monitoring solution, but why Sentry? One of the most important advantages of Sentry that I see is that it's open source and it has a small plan that is sufficient for many applications. You can either host it yourself or you can use the cloud plan. With the self-hosted solution, the error data does not leave your network, which can be crucial since the error logs may contain sensitive data such as passwords. Basically, Sentry gets all the basics right by default, but it also allows custom configuration for advanced use cases. So let's dive in and I'll show you a simple example setup. We start by navigating to sentry.io. Create an account if you don't already have one. Otherwise, sign in and go to Create Project. We will first create a PHP project, so select PHP from the platform filter, select it, and scroll down to click on the Create Project button. After creating the project, Sentry will display a simple Getting Started guide. First, we will create a new project. We open a terminal, navigate to the correct folder, and create a new directory where we can store our code files. I use Visual Studio Code as a code editor and start it in the newly created directory, and I will create a index.php file where we will demonstrate Sentry's functionality. As a simple debug output, we will just echo hello, save the file, and open a web browser navigating to 127.0.0.1/Sentry to verify that our test script works. Now we will get started by using Sentry's Getting Started guide and actually installing the Sentry SDK in Composer. So going back to our terminal, we can just paste this command from the Getting Started guide. Assuming you have Composer already installed, we'll answer no to this question because we want to create a new composer.json file. And after a few seconds, all the required packages should be downloaded and can be used in our script. We just want to quickly verify that everything has been downloaded successfully, so we will enter ls to display the directory contents. And as you can see, there is both a composer.json file and a vendor folder that contains the downloaded files. We now have to include the autoload.php in our script, so the PHP finds the downloaded files. So enter require once, vendor/autoload.php. And just to verify everything still works, let's just refresh our debug page, and yes, everything works. So we can go back, and now we can copy the second line from the getting started guide, which actually contains already the DSN for our newly created project. So this is the string you should not share, just include it here in our test script. And let me just make this window a little bit smaller and toggle the word wrap feature so we can see everything. And with this command we can tell Sentry which project it should report the errors to. And now to verify that this integration works, we will throw an example exception. So just to demonstrate what would happen if an actual exception would occur in your code. So we paste that as well. And open our web page again in our web browser. Now an exception did occur and our script sends the exception with the context to sentry.io. Under issues, we currently see nothing because it takes a few seconds for Sentry to process the sent exception. But after a few seconds, we can refresh and we will see one new issue. So here it is. It already says my first Sentry error, which is the text that we had in our exception. And we can now open it and have a look at what Sentry collected automatically. So you can already see we have one event with 0 users. I will get into that in a few minutes. If we scroll down a little bit, we can see the web browser of the user. We have a Chrome browser, PHP version 7.4, which is of course collected by the server, and also the operating system is collected by the server. And this is really cool. We can see both the URL that was called, and we can even see the source code where the exception occurred. In this section we can see the exact headers from the get call, and we can also switch to curl, so we can actually make a new call with exactly the same parameters to reproduce the error, for example. Yeah, if we scroll down, there is still more information that's not very interesting right now. So let's go back and open the page again. So I want to show you if we have the same error 2 times. Sentry does not a new exception issue, but it just adds the event to the already existing one. So now we have 2 issues. And this is a very useful way to keep track of how often your errors are occurring. However, if we change this text to something different, Sentry will automatically create a new issue for that, since it assumes that the exception has nothing to do with the exception before. So we refresh again, wait a few seconds for Sentry to process everything, and now we should have a second issue. Yes, here it is, a completely different error. So in this way you can get an overview of which errors occur when and how often. Next we want to assign a username to the exception. So let's assume that our user has logged into our application and his username is Bob, and we know that at this point in time. So we can now insert a code snippet, I will link in the video description below, to set the user. So we have this username variable and we set it in the scope of Sentry. And if we refresh right now, we can at first see, okay, hello Bob, this is just our demo script. But now under issues, if we refresh again, we can now see under the exception that we have one affected user, since now it knows which user it was. And we can see which user was affected by the exception. which is pretty cool. So if you have user management in your application, you can just insert the username or an ID or an email or whatever, and you can simply see which user it was that this exception was triggered by. Next, I want to show you that you can also capture messages without throwing exceptions. So just use the capture message function with a text, and you can run this and do not have to throw an exception, and the event will still be created in Sentry. So you can create issues directly using this function. And again, if we reload, which might take a second attempt since Sentry is still processing, or maybe even a third attempt, but here it is, loading data from database. So this is our custom event text, and we can send it to Sentry simply by using this function, and we do not need to throw an exception for that. Alright, now the next thing I want to show you is transactions. We first create a transaction ID variable, which is randomly generated, and just output it right now. So we want to represent an actual call of your application with a transaction ID that is generated newly on each new request. I want to show you that we can add this transaction ID to Sentry, and we will just move this code a few lines down when the transaction ID variable has been initialized. And we can add this new transaction ID as a tag in our scope. So use the set tag function here. We name the tag transaction ID, and we use this value of the newly generated variable. And of course, we will also need to add the transaction ID to our closure here. Alright, so now if we generate an exception, it will now also have this transaction ID as a tag. So let's just verify that. It is output, so this is the concrete transaction ID that was generated for this request. And if we refresh and look into the issues, we can now see that this issue has a transaction ID. And the cool thing about transaction IDs is that we can have multiple applications in multiple Sentry projects that use the same transaction ID. So if my application has multiple parts and one call of the application creates a specific transaction ID, we can now trace this transaction ID through a variety of applications. So to demonstrate that, I will create a new Python project. Again, enter a new name, let's say simple Python, create the project, and now Sentry will give us a getting started guide for Python. So we copy the first command, open our shell, create a new directory for our new Python application, paste this first command, and now pip will install the Sentry SDK. We will not have any files in the created directory because it's installed at system level. Oops, I don't have Vim, so let's use code. And we create this new main.py file and initialize it with this code that is generated by Sentry for us. And let's just assume that this new Python application is another microservice that we want to use in our application, and that PHP will call this microservice later on. So we start by initializing Sentry. We can remove those comments. It's just for production use and not really important right now. And now we can copy this exception generating code, which will try to divide by 0, which will cause an exception to be thrown. Save and run this main.py file with Python 3 in my case. And yes, an exception is thrown. It's also printing that it's attempting to send it to Sentry. So let's see if it was successful. Opening issues. We can now switch the project to the Python project we've just created. And we see the new issue with a 0 division error, which is just what we expected. So now we basically want to do the same as in PHP before, but first let's install Flask so we can have a HTTP endpoint to test. We create a new method and annotate it with app.route, so it's the index method. Just called it hello world, and as a simple debug script we will just return hello world and go back to our terminal. After commenting out this exception generating code, we don't need that right now. So going back to our terminal, we can now export the name of the script as flask_app and run flask run. And it has started our server on port 5000, so we can navigate to localhost port 5000 and we can read our example output. Perfect. So now we want to add the same username and the same transaction ID as before. So to do that, we want to read both of those variables from the request made to this application. So we define username as request.args.get username and transaction ID as request.args.get.transaction ID. So both variables will be input by the user that calls this application endpoint. And just as a debug, we will print both of them. So we will add both parameters to our request and hit enter. And of course, we at first need to restart our Flask server. Now, if we refresh, we get an internal server error. This is unexpected. Let's have a look at the log files. Oh, of course, yes. I just assumed transaction ID was an integer, but of course it's transmitted as a text. So let's just change that to string, refresh, and of course we still need to restart the server. And now we refresh and yes, perfect. So we have our username and the transaction ID, which is hard-coded to 5000 right now. Perfect. Next step, go back to Visual Studio Code and we will now import the necessary methods to set the user and the transaction ID. So we import two new functions. First, from the Sentry SDK, we need the setUser function. And as a parameter, we just need the username. So we move this line of code to the place where we have this username, which is inside the hello world function. and we just use the username variable that we receive from the GET request. So now Sentry knows that the username which has been passed by the GET parameter has also triggered the exception in this part of the application. Second, we also want to set the transaction ID, so we import the setTag method from the SDK. And similarly, we now set the transaction ID inside the hello world method. So again, the reason why we're doing this is that we want to trace exceptions through both applications. So we restart the Flask server, and due to scope reasons, we just move the initialization code also inside the hello world method to make this work. And if we save and restart the Flask server again, I'm missing a parenthesis here, so sorry for that. Save and restart the Flask server again. And if we now open the transaction, we get our exception. And now we also have the username and the transaction ID inside the Python application. So we have it now in both applications. And the plan is that the PHP application now calls the Python application and passes both the username and the transaction ID to the Python application. So now let's quickly implement that as well. So we change to our PHP application. And after we have generated the username and the transaction ID, we will just use a simple file get contents to call the Flask server on our localhost port 5000. As I said, we are passing both the username and the transaction ID directly as GET parameters. And it seems I have a typo here. Is it file get content? No, of course, I'm just missing a T here. Perfect. So let's save that. All right, looking good. So both variables are passed from PHP to Python. Looks also good. Let's start the Flask server and make our request inside PHP. We have our transaction ID starting with 52. So at first, let's see in our sample PHP project, we still need to refresh. Sentry needed a few seconds to process that. And okay, now we have our new exception. Let's go in there and see the transaction ID. Perfect, it's also 527. And now we want to make sure that the Python application has also an exception item with the same transaction ID. So we can see the filter here in this UI element. We now switch to the Python project, and Sentry will automatically save the filter, and perfect, we see the exception generated by the Python code with the same transaction ID. So this gives us a very powerful tool. We can now trace exceptions throughout as many applications as we want. We could have multiple backend services, we could even have a front end, and the user interacts with all of them. And if exceptions arise, we can now perfectly trace them with Sentry and get a perfect overview of our setup. So as you saw, setting up and integrating Sentry into your application only took a couple of minutes and yielded tremendously useful results. You are now fully aware of the exceptions that are thrown in your application. You can trace them back to specific requests, view the context, and get a big picture view of the impact. To learn more about the possible use cases of Sentry, visit their excellent documentation. The link is in the video description below. I hope that this guide was useful. Please let me know if you have any questions, and have a great day monitoring your applications.